in the, let's run it and see what it's going to do. And then, so what's happening here is I built a tiny little mock database element and a mock database. It does less than the prototype did and less than you're required to do for Project One, just for the purposes of demo. And I am creating an XML representation of that mock database. So here's just a couple elements of my database. Keys first and second, and the name is first element, second element, and they both are test elements, so their descriptions are the same. And that comes out as a, so my XML says DB. This is a database. And this is a database record, this is another database record, and there's two of them. If I had 5 records, there'd be 5 of them. And they're all named exactly the same. And that's important for reasons we'll see in a minute. Now, in that record, there's a key and a value. What? You know, this is a key value database. That's what they are. So a key is first. Now the value is structured. Yours has a lot more structure than mine. Mine intentionally is small. A, to make a quick, easy demo, and B, to give you less than you need. Okay. And anyway, so here's the value, and it has 2 children, name and description. Name and description. And key first, name first element, description test element, and so on. Okay. But yeah, that captures the database, right? Cool. So now I wrote that. What I'm showing you here is a string. This could have been, I could have written that string to a file. I didn't. You know, you can. Now what I'm doing is I'm taking that string and I'm creating a different new document. So I took my database and I created an XML document and I persisted that to a string. And now I'm going to take that string, imagine that that old document is gone. I wrote that 4 weeks ago. Now I'm going to come up and with that string create a new document, and from the document create a database. So we've just started up. That XML file was on the directory somewhere, and bingo, up comes our database, which is exactly what you're going to do to demonstrate that your database holds relationships, names all the packages in your design, and shows their dependency relationships, for example. So, and then we build a mock database from that. So let's see how all that happens. So I did change one thing. Let me go back to this. Whoops, I killed it, so let's rerun it. When you read with my XML document that structured, now what I'm doing is I'm structuring this and I'm saving this in a structured format. In other words, it's indented based on its, child-parent relationships. And I'm saving it that way. And what happens is my XML document, when it grabs this new line and that, okay, some extra stuff. Which is really what it should do, because all it knows is that I've got an element, I've got another element. If I'd saved this all in one line, you would have gotten just the text, okay? I'll come back to that point in a minute. But what I did do was I made one change to the XML document just to trim out that text. Not the only way to do it, but... So I went into, the only change I made at all to anything other than exactly what I gave you is in this XML parser create tagged element. So the parser is creating a whole bunch of elements as it's going along, is recognizing, okay, I've got this is a text element. So it's recognizing, okay, I've got a text element, so I need to, in in the string, in that XML, there's a text element, so I need to create a document element for that text. And so what I added to it I'm in the wrong place. This is create tagged element. I want create text element. Let me get down to create text element. Create text element. Here it is. So what I added, the only thing I added was from here to here. Forget this for a minute. While true, if is space, so text end is a string. String has begin and end functions. Okay, so text.end gives me an iterator pointing one past the last character in the string. Minus minus points to the last character in the string. And I'm saying, are you a space? White space. If it is, erase. Gone. Okay? And if it isn't, I break. I'm done. I've cleaned all that stuff out of the... Okay? 6 lines of code. You could have used my, I have a string utility that I gave you, and you could have used that to trim it, but that string utility doesn't trim off new lines intentionally, so you would have had to have tinkered with it a little bit. But anyway, it's real simple and easy to do. Let me explain this locale stuff. What the heck is that? So if I didn't use this locale, I'm just using the is space from the string namespace. That expects ASCII characters. And what that means is if you give it a Chinese character or a Sanskrit character or an Arabic curly character, okay, it's likely to throw an exception. Bam! Not my code throwing an exception, the library code throwing an exception. The library was originally written, back in the old days when that ASCII was what we had. Okay, so now there is a namespace. There's a header called locale, and in that locale is defined an is space which accepts a locale argument. So you create an instance of locale, add it to here, and that's smart enough. If you just create it, it will give whatever is the default locale, which in this case is English, okay? And it's perfectly happy now with those Chinese characters or Sanskrit characters or Arabic characters. No exceptions, just it isn't a space, and so that's what that's all about. So I made that one change, but there's 18 ways to skin that cat, so you didn't have to change. You could have done it. You could have done it externally, after you parsed it out and trimmed it in your reader. But so anyway, let's look at the help demo. So creates an XML document from a MockDB database, extracts an XML string representing the database, restores the database, builds a new MockDB from the XML string, and you will need to persist to a file and restore from the file. But it's just a tiny step of writing the string to a file and reading it from the file. To make this as simple as possible, I modified XML parser create text element by trimming trailing white space from the text. Okay, and if you look at those, you'll see, sure enough, if we go look at XML parser.h, it says, yeah, this is version 1.4, 31 January 18, added trimming of text end in XML parser create text element. Okay, it's your responsibility to kind of let people know what you're doing, if anybody's going to use the code. But you didn't have to do that. You could have used it just the way I sent it, and then all that means is that when you're pulling it out, now you get that extra new line and space stuff, and you got to trim it out there, and that's fine. Nothing wrong with that. Didn't need to do it this way. I just thought that's a good thing to do with XML. So now let's go on. If there's a question, I'll address them, but let me kind of walk through this, and then I'll answer questions after that. So I want to go to the help demo. So now, first of all, I build a little mock database element, and obviously it doesn't have everything you need. Don't want to give you everything you need. It just has a name and a description. That's all the element holds, is a name and a description. No payload, no relationships, none of that stuff. Okay, just keep it nice and simple. Because my purpose is to illustrate how you use XML document to do what we're going to do, to persist and unpersist. And now I have a mockDB, which is a little simpler than the prototype I gave you. You know, what it has is defines a key, defines a DB store. I am using an unordered map like the prototype does, and I'm defining an iterator in terms of the DB store iterator. And so I have a begin function and end function, so I can put this in a for loop, a range-based for loop, to step over the elements of the database, and I'm going to do that. And, you know, contains a little function to see if it contains the key. I don't think I even used that in the demo. I've forgotten. But and I have a function to show a single DB and a function to show the database, and that's what you saw on the printout. Now, here comes the stuff that you want. First of all, I'm just building the mock database, and so you all know how to do that, so let's skip over that. Now we have a functioning database that has two elements in it, so I want to create the XML representation of that mock database using XML document. So now, one of the reasons I'm doing this and doing this carefully is that I used standard shared pointers in my implementation of XML document. And the purpose of that is when you're using XML document class, elements are coming in and out, and you know, you're being passed around and blah, 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 blah. And if I passed them around by value as strings, big hit in performance. Copy, 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 copy. Okay? So instead, I'm passing around shared pointers, and those shared pointers, the size of that shared pointer is a single pointer. Got code above it that makes it smart, but it's just a single pointer. If you take size of, you'll find it's whatever the pointer size is on your machine, 64 bits or 32 bits or whatever your machine defines as a basic pointer size. So I'm declaring sPointer as standard shared pointer of abstract XML element. This is the interface for all of the XML elements. Now, there's a bunch of different kinds of XML elements. There's a declaration element, there's a processing instruction element, there's a text element, there's a tagged element, there's a comment element. I think there's a doc element. Remember that here we have this XML stuff, and sitting at the top is this extra node at the top called a doc element that lets the processor tie together the XML if there's any, if there's a declaration and comments and all that stuff, it ties it all together. Every XML processor I've ever seen uses a doc element, and mine does. So there's two things you have to be aware when you use this kind of XML processing. One is that at the top of your document, it has to be a doc element, and text bodies of an element are nodes. So that text is a child of the text element. Okay? Okay, so first thing we do is I want to make a DB element, so smart pointer DB. I have these little factory functions that make life a little easier for you. Make tag element DB. So I just declared an instance of the tag element and gave its tag name the name. That's all it did. And so as soon as we do that, we have now I have DB and I have NDB. That's all I have. Nothing in between. Okay? That's all that's there. And now, smart pointer to doc element, make doc element, PDB, that's making the guy at the top, and I can pass him, make doc element will accept, it has a couple of forms. One of the forms, it will accept a shared pointer that's going to point to your XML, the root. This, if you give it a shared pointer, it expects this to be the root of the XML. So, and PDB is the root of our XML. Points to the root of our XML. So I now have a doc element. So I now have two things. I have a doc element and I have the root of the XML, DB. And so DB is a child of the doc element. Okay? So what I have is and DB is a tagged element. Okay. So for auto item in DB, so remember the database had a begin and end pointer? So that's what allows me to use this range-based for. I give it the database that has a begin and end pointer, a function begin and a function end that returns an iterator to the first record and an iterator pointing to one past the last record. And I just steal those from the embedded unordered map, okay, from the DB store. So for auto item, now what's an item? Item is a key and a value. That unordered map is a collection of pairs where the first part of the pair is the key and the second part of the pair is the value. For us, the value will be mock DB element. For you and your project, it'll be DB element. Okay, so I'm stepping over the records. So S pointer P record equals make tagged element DB record. So now I got DB record. And PDB add child, this is a pointer to my database element, my root, add child P record. So I had created that and then I just added that child relationships. Now, smart pointer P key equals make tagged element key, item dot first. So what the heck is this? So this tagged element, I can give it both the key and the value at once in this factory function if I want to. It has an it defines by default this to be an empty string. But if I supply a string, it'll give me a angle bracket key, string text node, angle bracket slash key. So what's an item dot first? Well, item is this database item, and the first thing is a key. Okay, so here I am adding. So this is the text of that key. That's what's stored in that unordered map. P record, add child, P key. So now I have a key SPR P value equals make tagged element value. So again, here's what I'm doing. Here's key, we just made that. Now I'm making value. And for my mock DB element, that just has two children, name and description. For yours, it has more. Okay, so make tagged element value, add child. So now I have a value. Now this guy, because I added this here, this guy has the text node. And this is value. But here, notice no second argument, so its body now is empty. It's an empty string. P record, add child, P value, so I just added to that record the value node. Now, smart pointer P description equals make tagged element description item.second.description. So this is the tag name, and second is the value, key value, and that key value has two children, name and description, and it has a function called name, and so I said item.second.name, and that put the name text here. P value, add child, P name, so now I have a name, and it has an associated text node. Let me put this down so you can all see that. Okay. So I added the name, and now make tagged element description item.second.description, just like we did for the name, and now add the description. So now I have in my value description and a text node. Which is the text of the description. And it's going to generate two records. So there'll be over here, it'll make one more record, with just the same exact structure duplicated. We're done. And then standard string XML equal doc to string, and send that string to cout. So there it is. This is the cout. Voila! Voila! Okay. So now, this is a little bit more complicated, but not much. So now I'm going to create, this first part is simple. I'm going to create the XML document. So what I had is a xdoc, and I generated the string. So here I'm sitting with that string, and now I'm going to create XML document, new xdoc. So it's a different document, and I'm going to tell it, you're going to read it from a string, and that's the string, okay? XML, so I made that, when I said string XML equals toString, so now that's the string. So now I created the document. So now I have the document. I have the new document. And I displayed it. So here's where I displayed the old one. Now I read that string, and now I'm just displaying the new one. Okay. Now, let's build a mock database from that document. So, standard vector of smart pointer records equals new XML doc.descendants db record select. This is why you didn't name it record 1, record 2, record 3. Because if you named it record 1, record 2, record 3, you would have to make 3 statements. Give me record 1, give me record 2, give me record 3, and oh, I forgot what I named it, so I got to go look at some other code somewhere. Okay? But if you just name it DB record, they're all the same, give it to me. Got them. Now, what happens, what this descendants does is, in the document there is a vector called found. And you make any of these kinds of queries, and it just loads up found. Doesn't do it, it's just they're there and found, but you don't see them. Until you say dot select. Kind of like my query class did, you know. Oh, is that where you got the idea? Yeah, well, you know, this is my code too, so I can take credit for it. So, so now that's going to give me what found has is a vector, standard vector of smart pointers. And again, I'm using smart point. I could have used text elements, and I would have standard vector of text elements. Copy, 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 character after character after character. You know, if my database has 5,000 records in it, I spend 2 minutes waiting for it to do that. But here, these are pointers. Boom, bam, away they go. Okay. So now I got smart pointers to records. So these are elements, okay? These are just pointing into the element. Now, so for auto P record in records, so for each record, I need to define a key and a value. So here's my key, and my value is a mockDB element. All right? So standard vector of smart pointers p children equals p record dot children, and it's going to have two. The p record is going to have two children, a key and an element, key and a value, and that value is the element. Okay, so for auto p child and children, if p child tag equals key, key equals the text of that equals p child. So here I am on this key, but now I got to get its text child. That's why you have to remember that that text is a separate node. It's a child. And you didn't see it when we were building it, but those factory functions were doing that. Creating the text element, inserting it, editing it. So, so now key equals p child. Its children, it only has one, that text value. So p children of 0. That's this is a smart pointer to that node. That's a smart pointer to this node, and now it's using that smart pointer to get its child. So here is, I'm sorry, to get its value. So key equals p child of children of 0 value. The value is the text. If I go to a text node, what text node returns with a value statement is the text. If I go to a tagged element, the value returns the tagged element. Okay, so else, if it isn't a key, it has to be a value. Value represents a mockDB element with children, name, and description. Yours will have more. So now, standard vector of smart pointer p children equals p child children. And I expect them to be a name and a description. So now I'm going to do exactly what I did for the key. for auto p-val of children, I'm going to step over my children. And I wrote it. I could have just done this statement and this statement. If I knew I was forever only going to have 2, that would be the easy thing to do. But you're going to have more. So all you have to do is slide them into this loop. Okay? So if pchild tag equals name, element.name, so remember that element has a name function, expects a string. So now let's go get the string. P-value child, children of 0 value, that's the text node. I was pointing to the value element, I was pointing to the name element, and I just went down and grabbed its text. If p-value child tag equals description, element.description, children, value. So this line is, you got to bend your head around that. Remember this model that I have that tagged element key that points to a text node, or I have that tag value name that points to a text element. So get your head, around that, and then it's obvious. Now, in retrospect, every time I talk about XML document, I always say, gee, wouldn't it have been nice if I had made a function that makes this a little bit easier? And there probably is, and I didn't remember it, and so I didn't use it. This is, I know the mechanics, I know what's got to happen, so I did it this way. There's probably a function somewhere in XML document that does that for you. I don't know, but it doesn't matter. So now, voila, we're done. So for that record, I got a key and I got an element, so pump them into the new database. This is a new database, not the old one. So I'm adding it to the new database, and I'm looping over the records. So I'll loop it twice. There'll be 2. I show the database. And voila, there it is. That's the demo. Dr. Fawcett, you're doing too much for us. Don't give us all that stuff. Let us do it ourselves. What I do is I'm always late. So here it is, a week from your due date, right? No. It's due on, today is Thursday. It's 5 days from the due date. 5 days from the due date. So, and that's what I do. I'm kind of silent, letting you struggle with stuff and try to work it out yourself. And so 2 things have happened. If you figured it out for yourself, that's terrific. But now you have the opportunity to look at another way of doing it and say, do I like my way better? Sometimes you will. I like my way better than Dr. Fawcett's. That's fine. Or you'll say, gee, I like his way better. Next time I do it, I'll do it that way. Okay? That process is what puts it here. And if you've struggled with it and struggled with it and struggled with it and didn't make much progress, that's also fine. Now you say, I got it. The light bulb goes on. Yes, I see it. Now there's one other case. I didn't really do anything. I was waiting for somebody to do it for me. And you got nothing. You looked at it and say, okay, yeah, you forgot it. Nothing was added to your store, right? So it's really important that you bang your head against that brick wall, trying to, figure it out yourself. Really, really important. That's what makes a developer. We get these calluses on our head from banging our head against the wall, okay? And that smile when we finally get it. Yes! Okay. So, tomorrow there will be a help session in 2 waves. The project is due next week on Tuesday, so, I'm sure we'll have a pretty full house. So there will be 2 sessions, but don't count on coming to the second one, because if you do, if it's filled up, you won't get in. If you come to the first one and it's filled up, now you can get into the second one. Okay. So I will probably talk a little more. I'll answer questions anyway. So look at this, and if you've got questions about it, I can answer questions tomorrow morning. Also, I'll answer questions a little bit about query. So let me give you a little food for thought on the query. So there was a Piazza question that said, I have a template argument payload in my DB, so my query has to be templated on, so should I template my query? And my answer was basically yes, but. So what does the database, what does the query do when it does a select? It's comparing a condition against all the records in the database, okay? The value part of the record in the database just compares that condition, okay? So what does it do differently with the payload? It compares the condition to the payload. It's not doing anything different. So do I need to template it? Maybe not. But I certainly would need to template the condition class to make that comparison. Got to figure out how to make the comparison. So probably my template, my payload template might want to provide some functions to interact with the template, whatever you're doing, with the condition class. So it's giving the condition class whatever it needs, to flexibly. So I did template in my demo. I've forgotten whether it was the first or second demo last Friday. I gave a template member. I had select of condition, but I also had template type T select of T. And that was there so that I could handcraft a selection process that wasn't necessarily just comparing against a condition. I could do stuff. I could delete a record from the database with this handcrafted thing. So what that template type T member select does is it accepts whatever you want to give it, and it better, it needs to be able to do something, but I could pass it a lambda, I could pass it a functor, I could pass it a function pointer, any of those things I could pass it, and it'll do whatever I tell it in that lambda. So I can handcraft these queries. Okay. So I have a whole bunch of canned queries, and I have these handcrafted queries maybe, and maybe I'll save them, and guess what? I've got a stored procedure. Yeah. I could have done away with a condition, never had a condition class, and done everything with that select, taking a handcrafted. That would have worked. But I think it's quicker and easier. A lot of the cases are going to be, I want all the records with this name, or I want all the records with blah, 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 blah. So that conditioning makes a lot of sense. But I think it really makes sense to do both. To have a non-template method, select, that takes a condition, and a template method that'll take a lambda that does something else beside compare against conditions, okay? So, and I'm not going to do that out for you. I probably will, if I have time, I will do my own solution to Project 1 in case you get to Project 2 and you say, my database wasn't good enough. I can't build this repository with my rickety, shaky database. Then you could use mine. I think there's great value in if you can use your own, that is terrific. That's a pat on the back. You're patting yourself on the back. I did a good job. My database is good enough to use for project 2. If you can't, you gotta, well, yeah, but I won't do that until a couple of weeks into the project. I won't do that until a couple of weeks after you submit project 1. And the reason for that is that there may be a few people who really didn't want to work very hard, and they would grab that and they would change, 4 or 5 characters in it somewhere, put their name on it, and submit it. And we'd probably see that, but even if we didn't detect that the student did that, we're pretty good at detecting those things, but even if we didn't, he's lost 14 points because it's 2 weeks later. Okay, so he's starting out at an 86, and surely it wouldn't have been 100 anyway. So anyway, if I have time, I will do that. I don't promise you that I'll do that. I've already given you quite a bit, but if I have time, I'll do my own solution. So that's the walk you out at the end of the dock, throw you in the water, see you going up, and if you go down for the 3rd time, I'll throw you a life preserver. So that would be a life preserver. Questions about what we've done so far? I'm about ready to turn to templates proper. Yes? I can't hear your tiny little voice, my old ears.
Like a library-related question to the unnoted map library. Like it said, I constantly, if I read like the reference page to it, said like, well, in the end it returns an iterator that points to the past the end.
One past the end.
What does that mean?
It means whatever that library means. What it guarantees is that what it returns with end won't equal anything that it returns when it points to a valid member of the what's contained in the container. It just guarantees that they'll be different. And so I can test when I'm stepping over elements. If I test, if I get to end, I know that it doesn't match any element in the database, and so I didn't find what I was looking for. Okay? Good question. Okay, let's talk about templates. You already know all about templates. You've been working on this nice template project. Okay. There's a quick overview that I'll let you walk through again. It talks a little bit about it. I pointed this out to you before. Notice that, this is a class, and it's prefaced with template type name T. You can use either the keyword class, C-L-A-S-S, or type name. Either one works. When templates first came out in C++ 93, the only thing you could use there was class. In C++ 98, they changed that to type name, and they would really like you to use type name, but they accept class so they don't break all their code. So you can use either type name or class, but so it's preferable to use type name. In my slides here, in these slides, not this one, but in the slides we're going to look at in a minute, most of the places I use class just because it's smaller. It lets me write more on that tiny PowerPoint page. So, but type name is preferable. So anyway, let's, you look at that. If you haven't already, you should have. I expect you did. So let's look at this templates presentation. Okay, so today we're going to talk about basic templates and specialization. I may get to template parameters and template members, I'm not sure. If we don't, we'll talk about them on Tuesday. I may even get to partial template specialization, we'll see. And then there's a bunch of other stuff, more details that we'll get into. Definitely that will come on Tuesday. Here's a simple example. This is a template function. Template type name, and so here I've used class, but these days template type name is preferable. Template class T, Tmax, const T reference T1, const T reference T2, return. This is a ternary operator, and the way this works is this is a predicate T2 greater than T1. If it's true, it evaluates to this, T2. If it's false, it evaluates to this, T1. And that's what's returned, and so that's exactly what you want. Okay? Ints, great, works like a charm. Doubles, great, works like a charm. What do you think happens if I enter the literal string aardvark, comma, the literal string zebra? What do you think it will return? You think about that for a little bit, and I'll come back to that. You might suspect that because I asked that question that way, that there's a little trick here. It may not be obvious. So instantiation, we instantiate that function when we use it. This is an instantiation. So this says int x equals max of 2 comma y, and the compiler is doing some inferencing here. 2 could be a double or an int. Compiler doesn't know when it scans this expression. But y, it knows is an int. It looks up y in its symbol table and says, aha, that's an int. And in max, these were the same type, so it says, okay, 2 is an int. That's how I should interpret it. Okay? And it'll return, since y is 1, this should return 2. Now, I could supply, so if y were a double, I could have a double, and I could provide, let's say y was equal to double y equals 2.5. And then I say max 2 comma y. Now the compiler says y is a double, and so this is 2.0. Or 1.99999, whatever the floating point unit does. Okay? Now, if y is an int and I put 2.5 here instead of 2, the compiler says int, that's an int, and it says, aha, I can convert with loss of significance 2.5 to 2. My rules allow that conversion. And so it will do that. When it compiles, you should get a warning that there's loss of significance. Okay? I hope you will. But that will probably succeed. Okay. So the compiler is inferring, doing a type inference on these parameters, and that type inferencing is very, very useful. It's what makes lambdas work. So I had this template method select in my query. And now if I can provide a functor, I can provide a lambda, I can provide a function pointer, and those are all different types. But it'll accept any of those, and the type inferencing says, aha, this is a lambda, okay, and treats it accordingly. So here's that question posed again. So what do you think happens if I call that function? What will it return? How many think that aardvark will be returned? Raise your hand if you think aardvark will return. Raise your hand if you think zebra will be returned. There's a bunch of you who are unwilling to say, because you know there's something coming. So understand that this is a constant char star pointer. What I'm passing it is a constant char star pointer that points to some place that the compiler reserved memory for that literal string. And this is a char star pointer. And when it compares that char star pointer, less than, whoever is higher in memory is what's returned. Okay? So on a Windows machine, if I declare zebra first and aardvark second, I'll get aardvark. If I'm on a Mac and I declare zebra first and aardvark second, I'll get zebra. because the big endian, little endian switch. I think though. That's my quick mental model. But anyway, it isn't what you expect. And you say, oh, gee, that's a problem. But there's a solution right around the corner. Nice, nice, nice solution. So, template functions. The solution is called specialization, and we will talk about specialization this morning very soon. So, here's another function, and this function is swap, and it just, so what it's doing here is it's creating, whatever the types are, it creates a temporary of argument T1, it assigns T2 to T1, and then it assigns temp to T2. So this works as long as those operations are defined. Now remember that the compiler will always generate assignment operators and copy constructors, always. So this will never fail to compile. But if you have a class that does not have correct copy and assignment semantics, it will not operate the way you expect it to. So the moral of the story is, remember the rule of threes. If your class has correct copy and assignment and destruction semantics, don't supply them. Okay, the compiler generated one is just fine. And if you don't supply them, the compiler will generate them, and this will work just fine. If it doesn't, you supply them, and this works just fine. The compiler will use your supplied functions. If you don't supply them, you should delete them, and now this will fail to compile because it will say these operations have been deleted. The copy construction and assignment have been deleted, fail to compile. If you don't delete them, it'll operate incorrectly. So the moral of the story is, remember, the fundamental thing to remember is the rule of threes. So if I have a class that has primitive data and STL containers, that's very, very common. Probably 80% of the classes I define have that. I don't need to provide them, and I don't. Okay. So none of the processing in this example depends on the actual type, but it's expecting that the type has those operations. Now, C++ does a nice thing with templates. It does a lazy analysis of that. What happens is the compiler looks at that and says, that code looks correct. Remember, when it's compiling a template library, it's not generating OBJ code, doesn't know the types, it can't lay it out. Okay? But it does the syntactic check and says, you pass all my syntactic rules, great. Compiles just fine. Now when I instantiate it, if I have deleted the assignment operator, then it fails to compile. And that's good. So for all the cases where I've supplied a type with the correct operations, it all succeeds. By default, just succeeds. But if I have some unique case, it'll fail to compile, it'll tell me, and I know what to do. So this is a lazy analysis, and that is great. C# and Java do not do that. C# and Java, with their generics, will say, you're using an operation, and I don't know that that type supplies that operation. Fail to compile. End of story. Ever. Fail to compile. The only way to get that to work is to provide an interface that defines those operations. In this case, Java and C# won't fail it because these operations just handle operations, but probably not doing what you want. Okay, but so in C# and Java, if you use a function, the compiler will insist that you've demonstrated conclusively to it that it has that function, and the way you do that is to provide a constraint declaration that says this type inherits from this interface, and that interface has the method I'm using in this function. And the result of that is that when you use generics in C# and Java, you're littering up your code with a whole bunch of these little tiny interfaces to convince the compiler it's okay that you don't need otherwise. Really annoys the heck out of me. I like that lazy analysis. Why not do the lazy analysis? Failing at application time is just fine. We do the easy thing for the library as a whole, and at application time, if it fails, the same thing is true of C# and Java. If it fails, you got to go do something. Here, you got to go do something. But here, by default, it'll just work. I'm biased. I admit, mea culpa. I'm biased. I like C++ better by far. But C# and Java are good. I like, Okay, so template classes. So here's a stack class, template type name T, class stack, public stack, push pop, template type name T, stack stack. And you say, gee, the term stack appears in 5 different places. It appears 1, 2, 3, 4 different places. Some of them have an angle bracket T and some don't. How do I know which to use? And the answer is, if stack is used as a type, you must include angle bracket T. If it's used as a function, as in the constructor call, you don't. In fact, you shouldn't, because it won't compile if you do. Okay? Because this is not the template type, this is just a function. We're going to look at, on Tuesday, we're going to look at some sample code. And in that sample code, there's a stack class. This stack class is there, and you can look at it if you want. But. Template class instantiation. So if we instantiate a class, we instantiate a class simply by saying stack string, my stack, stack int, your stack. And what the compiler does is it generates 2 different stack class definitions. Stack of string over here in code space, stack of int over here in code space. 2 different places. If I have a static member in that template, a static member is shared by all instances of the class. But stack of int is not the same thing, not the same class as stack of string. What that means is that all instances of stack of string will share its static, and all instances of stack of int will share its static, but stack of int will not share the static from stack of string. And we will use that in our communication channel. If you look at the communication channel, this is there now in the class. If you look at it, I haven't used it yet, but we will. So, okay. Another thing, just a reminder, header files contain only non-template class declarations, non-template inline function definitions, but not, you have to have the inline qualifier, or template declarations and definitions. And the reason for that is, when you compile the template class, it can't lay out code. There's no OBJ file that's generated. Non-template classes, as soon as you compile them, there's an OBJ file, an object file, that has that binary representation. But for a template, the compiler cannot lay out code for the template because it doesn't know how big T is. You have to know the size of every single type in order to lay out code. So what that means is that when my application pound includes the template class header file, the definitions have to be compiled. And the only way it's going to get those definitions if they're in the header file. So template functions and classes have to have both the declaration and the definition in the header file. There have been a couple of schemes that were attempted. There was a scheme called import there was a keyword import in C++ 98, I think it was, and nobody got it right. Everybody got it wrong. One compiler, a German compiler, got it right, and it worked, meaning I could put my implementations in a CPP file, and it made the right. And it would sometimes work and a lot of times not work in Visual Studio and GCC and Clang and all those guys. So they finally said, this is a bad idea. We're going to abandon it. And that import keyword was removed. They are still thinking about that. The C++ committee is working on something called modules. And in modules, their intent is to take care of, so that you can't put that. I don't think that's a big deal. I wouldn't lose any sleep over the fact that just understand that that's the way. You understand why. Makes sense. So what's the big deal? The issue, of course, I did a wraparound here. The issue, of course, is that, gee, we're giving away proprietary. People are going to reverse engineer your code no matter what you do, so don't worry about it. Okay, so header files contain only non-template declarations, non-template inline function definitions. That is, inline, you have an inline qualifier. If you put a function, non-template function declaration in your header file and you don't qualify it as inline, it'll compile fine, but the linker will say multiple definitions fail to build. Bam. Because every folder that includes that file, every package that includes that header has that function definition, so that function definition will occur in a whole bunch of places in those different files. That's what the linker is complaining about. I saw that function definition in this package, and I saw that function definition in this package, and I saw that function definition in this package, if those three packages included that header file. So the inline is an instruction that says, is the compiler, only put this in the link map once so the linker doesn't get confused. And it also, instead of creating a stack frame and jumping to code in some, in code space, it just takes that code, bam, puts it in line, bam, puts it in line, puts it in line, if it can. And what that means is, A, it's not more than 3 or 4 lines, B, there's no switch, no conditionals, and C, no loops. If it has conditionals or loops or is too big, it won't be inline, even though you've said inline, but still the link map is handled properly, so it works just fine. I don't use inline functions much. I did use them in the utilities I gave you because I wanted you to be able to just pound include the header file for the utility and use it without having to go dig out the CPP and move it and put it over here. Just include the header file. So for small utilities, it makes sense to do that. But for anything else, you really want to have the package, do the package properly, CPP, header file and CPP. But anyway, that's that. There's some rewrite rules. I wrote this to help you understand the syntax. So what it says is, suppose I created I want to build a template class, so let's build one for an int, and now here's how you have to change it to make it that class for type T. And all I'm doing is comparing it. Here's how you say it in a non-template class. Here's how you say it in a template class. You're not going to do rewrite. You won't start by creating an int class and then converting it. But this is just showing you the differences. So if I have a non-template class, I write class name. But with template, I say template class T or type name T, class name. If I, for each member function, replace return type class name : member name, where I'm defining that function, now this has to become class name of T. That's all. So it's doing that comparison, showing you what you have to do differently if this is a template file. So this slide is worth a 5-minute look, and then put it aside and never look at it again. You don't need this for the midterm. Okay? This just here is a little crutch to get you going with the syntax or template classes. Template parameters. So I can put things in a template that are different than types. First of all, I don't think I said that here on this page, but I can have multiple types in a template definition. I can have class T, class U, class V. There's a lot of very often reasons to do that. We'll see some on Tuesday. And so here's a template definition with a class, and now stack of widget, my stack. So this is the template definition, and this is the application instantiation of that template. I can use native types like int and double. So here's a template class T of int I, buffer. So now I would instantiate that as buffer of char 255. That says I'm going to have a buffer of size 255, and it's going to accept characters. Do you save enough to be with this to make it worth making a template out of it? I never thought so. Strauss has this as an example in his book. But it's so easy to just declare the buffer that you don't really need a template to do that. But it illustrates that, and there are places where using an int is important. If I have a class templated on some particular concrete type, so it's templated, it's a template class, but now I'm going to instantiate it like a communication type instantiated on message, and it's got a static. And now I want another communication instance, and I don't want it to share stuff with that other communication class. Then I could say com1, com2. Templatize com on that integer, and that's just a category that says, so I might use enumeration, which one said, com this part, com that part. That doesn't mean that you're saying, well, what's com going to show? We'll talk about communication, and it'll become obvious when we talk about it. But that's a case where you might use it. We can use other templates. So this one is template of class T, but now I want to parameterize it on some other class V, but I want to tell it, whatever I'm templatizing my class on, this T, I want V to be templatized on that same T. What did he say? What? What was that? So I have a class T, simple type, but now I have a template type. And I want this template to be instantiated on that type, whatever it is. I don't know what it is, but whatever it is, I want this class to be instantiated on the same type that so I want V to be instantiated on the same type as my class is. That's all. And it has a little bit of syntax. It makes the client, it's a little slightly more complicated for you to design it, but it makes it slightly easier for the client to use it. We'll see. I'll show you an example perhaps on Tuesday. I'm not sure we'll get to it, but if we do, I'll show you an example on Tuesday. And that's always a good trade-off. You're going to design it once, and other people are going to use it 400 times if it's a good class. So you're trading off the extra 10 minutes for you to write the class against the extra minute of confusion for 100 times when it's used. Okay, so that's a good trade-off. Make it a little more complicated for yourself to make the syntax a little better for the client. What would happen, the reason real reason you're doing it is, it may be important that this class is uses the same type as this. That V is templatized on the same as my class. And it won't work properly if it isn't. And so this is avoiding that situation. V can only be instantiated on the same type as I instantiate my class. And so now it's safe. That's a better reason for doing it. Okay, now I can instantiate on constant expressions. So before there was a thread class in C++, I designed my own, and we used it in this class to do, communication channels and all the stuff we do. And I defined two types of threads, a normal default thread. So here's the thread, you give it a processing function, and away it goes, and when it's done, it's done. But I want to have some threads that just run, and I'm paying no more attention to them ever more. They're just doing their thing. So if I may create that thread on the heap, create the processing function on the heap, and the model of this terminating thread is when the thread function finishes, the first thing it does is it deletes its processing function, and then it deletes itself. Delete this. Okay? Harry carry. Seppuku. Suicide. Okay. If that puzzles you, don't worry about it. We have a nice thread class, and so you don't need to worry about it. We won't use my thread class. You can even put a function pointer into a class. I could make a templated class that worked a lot like a delegate by doing this. If you took SMA, you know what a delegate is. If you don't, it doesn't matter. Just saying, you could take a function pointer. Why would I ever do that? If we have time, I have examples showing that, and if we have time, we'll talk about it. If we don't, I'll say, hey, go look at that. Okay, template members. Template members, how are we doing on time? Yeah, we got a few more minutes. Template members. So here, a class may define members to be templates. So this is a smart pointer that will point to objects of type T. And the smart pointers, normally what they do is when they go out of scope, they delete that thing from the heap. Now, I may want to convert a smart pointer that points to a U to a smart pointer that points to T. Now, that'll only work if U is convertible to a T, okay, but a lot of times it is. And so this allows me to build a template class that this happens to be a promotion constructor, so I could take my smart pointer and I could promote my a smart pointer of a different class to my smart pointer, but that type has to be convertible. If he's pointing to a widget and I'm pointing to a super widget, then there has to be a conversion between widgets and super widgets. Okay, that's all. Do you do this all the time? No. But in the demo I did, the little tiny demo, I think it was either the first or second one, I don't remember which, last Friday, I had a query class that had a template select member. So the model was that I select on condition types, but like I said early in the class, I can also select on some arbitrary, select on a function pointer or a functor or a lambda, and that lambda can be handcrafted to do stuff like delete an element from the database or something like that. A query wouldn't normally do that. Querying against conditions won't do that. But with that select, I could do that. Okay. So good reason to use a template member for that select. You don't need to do that for project one. You absolutely don't. But my demo, if I have time to complete my solution to my solution to project one now exists exactly in those two, this help demo that we just looked at this morning and the prototype NoSQL-DB. That's where I am. But if I have time, I'll wrap it up as a solution to project two, and 2 weeks after your due date, I'll post it and we can look at it. And I will have a template member, a select member, and I'll show you how it works and why you might want to use it. Good, we got 5 more minutes. I'm going to use every one of them. Template specialization. So here comes the nifty stuff. So here I have this max function, and I want to avoid the problem with literal strings. I want to be able to use max on literal strings. So what do? I define a duplicate of this, another function called max. And if I make a exact one-for-one substitution of t for some concrete type, it's got to be exact. So here I'm returning t by value, here t by, it's got to be identical. If you change it in any way, this won't work. But if it's identical match, then what happens is the compiler guarantees that it will use your specialization for that type, not the generic template. So here I've said type t char star equals p char. Empty template, the syntax or specializations, const p char, okay, max const p char by reference, const p char by reference, okay, and now I'm using the C-style string lexicographic string compare. So the language guarantees me that if I pass it a literal string, it'll call this one in preference to that one. But if it can't find a specialization, it'll call that one. That means that I can provide this general template, and I can take care of special cases where that general template didn't work. C# and Java generics do not support specialization. The reason they don't is C++ templates are compile time, and this specialization is a compile time event. The compiler sees that invocation, and it says, it's already compiled these two, and it says, which one do I pick? C# and Java, a template, a generic container, for example, is really, under the covers, a container of objects. And your type, you cast in, you cast from that type to an object, and going out, you cast from the object to that type. So it'll fail, but it'll fail at runtime with this casting error. Okay. In C++, it'll fail. So what will happen here is if it can't find an instance, it'll try to do this. And if you have a method that clearly, there's no way for the compiler to generate it, the compiler will generate this. But if there's no way to, then it'll fail at compile time, which is good. But understand, you got to remember the rule of threes, Got to remember the rule of threes. So the problem, here was that pointers, there is a comparison of pointers which just compares the addresses. That's the problem. Okay, so I am going to, I'll talk about this one slide and then we'll quit. It'll take me a minute, and that's what we have. We have 1 minute. So here's a generic class T widget. So specializations are a narrowing of the set of objects that can be applied. So here, I can apply any T that's a user-defined type. And template class T star, this is a narrowing. I can apply this to any type that is a pointer type. If it isn't a pointer type, it'll use this one. But if it's a pointer type, it'll use this one. And so if I need different syntax for those pointers, I can put it in the implementation here. This is a full specialization. So here, this is all for the widget class. So this is a widget class where I'm passing some T that isn't obviously a pointer type. Here's a widget class that I am passed a pointer type. And here's a widget class that I get a string. And they probably all three different. I wouldn't do the specialization unless I wanted to treat widgets of string differently than the generic algorithm. Okay? So unspecialized, partial specialization, full specialization. And this is a syntax. Full specialization has an empty set of parameters. Partial specialization has something here. This is still a template, still has an undefined parameter. So we'll continue this next time on Tuesday. There will be a help session tomorrow. I'll talk a little bit about, I will answer questions about persistence and queries, but I'm not going to tell you. I'll help you understand what we've done, but I'm not going to give you any more stuff. You know, you guys are experts at, oh,